Tonight's talk is on running an open source project at low cost and large scale. So there we go. Who am I? So I've been working with Linux not quite as long as you, 21 years. So it's been a while. Been a software engineer for 30 years, but professionally just about those 21 years. I work for Panasonic, and it's a mouthful because we have all kinds of different divisions and sections and groups. So I am part of Panasonic Corporation of North America in the group that's called Corporate Technology and Strategic Partnerships, and I'm part of the Software and Analytics Solutions group, which is based in Salt Lake City. I'm the Director of Professional Services there, so I'm over a couple of different teams. One of them is a development team that works on solutions, applications, using the open source technology that we're talking about tonight, OpenDOF. And I also wear another hat as part of the OpenDOF project, which was kicked off last March, by Panasonic. Panasonic is the only member of that organization right now, but hopefully we can get a few more to sign up. And the OpenDOF project is, OpenDOF stands for Open Distributed Object Framework. And it's basically a set of libraries, tools, protocols that allow you to very easily connect things together for the Internet of Things. So it's works all the way down on embedded devices in really, really small footprints on up to cloud enterprise solutions. So, and I'm the Developer Support Working Group Chairman and also on the Technical Steering Committee of the OpenDOF project. There's some of my interests, to name a few. Have a lot of different interests that I've collected throughout the years, and most of my day job, at least before I was a director, was to work mostly in the networking and security areas, doing a lot of API design, and of course Linux. Everything was, I focused on primarily Linux, although my desktop machine was Windows. I just ran a VM or had another alternate dev box. So we had a challenge as we were trying to open source our technology, and that was we needed to launch an OpenDOF project, and we wanted to keep all of the intellectual property and all the assets and artifacts kind of to ourselves. We didn't want to put it in the hands of somebody else to manage or mismanage, as the case may be. And we also didn't find any really good solutions for everything that we wanted to do. So there are certain solutions like GitHub works really well for source, but when you want to get like a binary out there, distribute things, it's not exactly the best platform. You can clone a repo really quick, but when you want to have other artifacts that are built from that source, then you need to find another solution. So we wanted something that was a little more integrated, a little more cohesive. The other thing that we wanted were integrated tools. So things that worked well together, or at least we could hook them together relatively easily. And so that meant things like our source code repository, our defect tracking system, we want continuous build automation and continuous test integration. So as things as we build things automatically, they'd automatically get tested as well. We also wanted a worldwide large-scale distribution capability. As Panasonic, we often work with teams in Japan, Singapore, Europe, all across the world. And so when they need a copy of our technology, one of the things that happened was it was really slow for them to get a copy of whatever they needed. If we tell them to go get an update, it would be a long time to get that update because it has to cross the ocean. And unfortunately, the internal network at Panasonic is not the fastest in the world. So doing things outside of Panasonic with the cloud actually is a lot faster than doing things inside on the Panasonic network because there's only a few connection points Inside Japan, it's great. Inside the US, it's not too bad. But once you cross those geographic regions, there's really, really small pipes. So we wanted a way to get that distribution to be easy and all over the place. We also wanted a complete web presence. So what that means is basically we wanted to foster a community and try to get some transparency on our protocols, on our technology, on our source, and get other people to understand it, to use it, and to start building things with it. So we started off looking first at what kinds of source control we wanted to have. As an open source project, you kind of need to control your source. So one of the things that we've had a lot of experience with is source control over the years. We were a very small company that was bought out by Panasonic, and in those days we were using Visual Source Safe. Don't laugh too loudly. None of us liked it, but that was the choice of the company, so that's where it was. We moved from that. We'd actually had some things in CVS for a while, and then we moved to Subversion. I believe that was about the time that Panasonic bought us out. It was kind of the new and upcoming thing at the time, and so we latched on. It was great, and it had its purpose. But it has some deficiencies as well, especially when you're talking about distributed or doing merges and branches and stuff. It can get kind of hairy. So we were really interested in Git, and we heard a lot about it, had some questions about it, how it might work, but we thought, that might be a good approach to take for our new open source project. As we got into it and looked at the tools, looked at the capabilities, it was actually kind of nice. Put a lot of our fears to rest, and so we started looking at good solutions for where we could host that. And so there's the obvious places. SourceForge is one. Actually, I'm not even sure that they do Git. Do they do Git? Okay, because they're kind of a older thing. I remember going to SourceForge many years ago to get some open source projects. And so they're still around, but they're kind of waning in popularity in favor of things like GitHub. There's Google Code, which was an interesting project by Google to try and host a lot of different open source projects. Turns out that's now canceled and kaput. So they're trying to phase that out anyway. I think, I can't remember if they've officially closed the doors on it, but they're not accepting any new projects. There's also CodePlex. I don't know if I wasn't even aware of this one until we started looking. It's a Microsoft solution. It's really good for Microsoft projects, not so much for other kinds of projects, and it turns out Microsoft even abandoned it, so that was out. GitHub was obviously our next choice. Heard a lot about it. As it turns out, though, GitHub is not the same as Git. GitHub puts a lot of process and additional tools and things around Git, which are useful and helpful, and we liked, honestly, but there were some nuances about how GitHub worked, and we weren't sure that we wanted to put all of our source on GitHub itself, and we wanted a little bit more control over it, and so we looked at GitHub. We actually asked them about doing an on-site installation, kind of installing our own GitHub, and the licensing for that was insane. It was crazy expensive. And as our open source project, we're like, no, we're not going to be able to afford that. We want a much simpler solution. And so along came Bitbucket. I don't know, anyone familiar with Bitbucket? Okay. So Bitbucket is a tool from Atlassian. I don't want to be like an Atlassian proponent here, but it really is a cool tool. So we came across it, heard about it from a couple of different places, but came across it and found that it seemed to have pretty much all that we wanted from GitHub. But as an open source project, Bitbucket is actually free. not only just for their cloud solution, but you can actually install one on your own servers if you want. And that you can get a license from them that is free for that as well. So we thought, hey, you know, if they're going to provide a free license to that, we might as well start using it and see what it's like. So we set one up and started using it, playing with it, and found that we really liked it. So it was it's kind of what we wanted to go with. So we chose Bitbucket. The next part was trying to figure out what to do for issue tracking. For a long time inside Panasonic, or inside our group inside Panasonic, we had actually worked with a bug system called Mantis. Mantis is pretty simple. There's not a whole lot to it. It actually works really well. It's a PHP-based solution, and it works pretty good. But there are some things that we wish we could change about it. We could certainly dig into the code and write it, but that's not our forte. We didn't want to be writing our own solution, really. And so we wanted something off the shelf. Mantis was a good option, but we felt like we wanted something a little bit more. And so we looked at Bugzilla as well. We had some experience with Bugzilla in the past. And actually, I should back up for a second. One of the things that we identified as a challenge for issue tracking is that there's kind of this difference between a defect and an issue. And it was a little bit new for me to think about because I've mostly been in the code area, and I thought everything was just a defect or an issue, or I called it the same thing. It was a bug. All right, you write a bug, I go fix it in the code. Simple enough. But as looking at a little bit higher level, there's really kind of two different audiences for bugs and issues and defects and whatever you want to call them. One of them is kind of the customer view, and that's kind of feature or functionality based. Like, I'm trying to do X and it doesn't work. I don't know what's wrong. I don't know a thing about the code, but I'm trying to do something and it's not working the way that it says it should, or the way that I think it should, or whatever. So that's what we're going to term an issue. And it's kind of a higher level, something that you could actually write a system level test around and put it into a test plan. A defect we define more as an actual specific issue in the code. More useful for the developers who actually work on the code, because, hey, you know, X says it should be 7 here, it's actually set to 5, we need to fix that. Or, you know, this algorithm isn't quite right, there's something going wrong in this algorithm. It's something a little bit closer to the code. An end user probably doesn't care about that, but there are likely going to be multiple defects per issue. So an issue, something isn't working, that means there's a problem here in the code, there's a problem here in the code, there's a problem here in the code, whatever. So that's kind of how we were defining things. And so Mantis is really good for tracking those defects. Not so well on the issues. There's some hierarchy you can do, but it's very, very simplistic and basic. Bugzilla, a little bit better, but still focused a lot on the defects. And we liked it, but we were still looking for other options. As it turned out, we had a meeting actually with Salesforce, and they have lots of interesting things that I never thought of Salesforce as doing. But certainly one of their big products is kind of a customer relationship management software, and it definitely handles issues. That's one of the things that people, especially salespeople, want to track with their customers, is that you know, if they're having a problem, they want to be able to track that, manage that, work with the internal teams to get it resolved, and then let their customers know. But kind of like how Mantis and Bugzilla are focused more on the defects, Salesforce is focused more on the issues, not so much on the defects, and there's a lot of overhead with it. So we weren't so sure about that one, plus a lot of licensing fees. And we also heard about Jira, which is another Atlassian product. Has some really good integration with Bitbucket, and it had a lot of really good features. It's very flexible, very customizable, and quite honestly, we just stopped looking at that point. It's like, hey, this one looks like it'll work great. So since we had already chosen the Bitbucket, Actually, it was Stash at the time that we chose it, but it's now Bitbucket. We decided to go with Jira, and Jira will actually do a lot of the user management, and you can hook up other Atlassian tools to that user management. So we actually set up the users through Jira, and then Source connects to that, and it has some really nice integrations so that when you create a branch in Git, it shows up in the bug system. It says, oh yeah, there's a branch been created for this bug. In fact, you can tell the bug system to create the branch for you in the source system. That's kind of cool. And it can track, all the changes that happen with that bug when the bug gets resolved. You can set up certain automatic flows. We have not done that yet, but you can certainly set up some automatic flows so that when you make a commit and say you merge that branch into the trunk, that can actually trigger the bug to be closed automatically, or not closed, but resolved, send off a notification to QA so that they can test and close the bug if they want. So a lot of really good integration with Jira. So that's the one that we chose. With source and defects out of the way, we wanted to look at the build process and figure out how to get the build process to really work well. And taking just a little bit of a tangent from everything, I wanted to talk a little bit about the build process itself. One of the main things with a build process is that you want to have a repeatable, maintainable build whenever you check in a change. So if I check in something, I build something, I have this kind of a golden artifact, if you will, and has a certain version on it. And if I distribute that elsewhere, I have all the information in that in order to reproduce it and reproduce it exactly. So using this automated system rather than having it built on some developer's machine where they have some weird library or some version of some library installed, we've actually had problems like this in the past where you build something on the developer machine, you give it to somebody else, and all of a sudden they can't run it. They get an exception in Java, or they get a DLL load error on Windows, or whatever. And there's a problem because the developer system is different than the customer system. And so what we wanted to make sure of is that our build machines are very pristine, very clean, have just what they need in order to build the software. And so they build it repeatedly, and it just makes it so that we can reproduce those builds very easily. We had a lot of very unique requirements of our build process as well. So as OpenDOF, we're trying to be kind of a jack of all trades, so to speak. We cater to a lot of different and very, very varied platforms and environments. So we support Windows, we support Linux, we support C, C#, Java, and we have documentation tools that run, some in Windows, some in Linux. And so we needed a build system that would handle all of these cases kind of effortlessly and without trying to shoehorn them all into some convoluted system. And so there's two main parts to a build process. One is dependency management. You need to be able to figure out I guess I should move on here. There we go. Dependency management. So being able to determine the transitive closure of all the dependencies that are required to build your software, and collecting and downloading those dependencies, being able to acquire them, and then also being able to track them. What was actually used to produce this build? Was it version 3.4 of some library, or was it version 3.7? And how do I know that? If I download it, should I use the same version? Should I use some other version? How does all that work? And so we needed to be able to track that and report that. The other major part to the build process is the actual build execution. So you need to actually compile code, or link the code, or generate documentation, or run some tool to produce some output or some artifact. And so both of these pieces to the build have to be covered, and we needed solutions that handle both of those. So obviously there's GNU Make. We were very familiar with that. I think there was a comment on the mailing list about GNU Make. I've actually been working with it for somewhere around 18 years, maybe 20 years. So I'm actually quite familiar with GNU Make. It's very capable, very robust, does a lot of things, especially when you know how to use it. I rely a lot on the online manual, honestly, because I can't remember everything that it does, but it does a lot of really cool stuff. So I'm familiar with it, but not so many other developers are, and as it turns out, it's not as portable as you'd like it to be. So it works fantastic in Unix environments, but as soon as you go to Windows, you're kind of out of luck. You either need to run SIGWin or MinGW or something in order to get, actually I think GNU now has a Windows port for their Make system. But still, trying to get that to work is a little bit of a challenge sometimes. There's also CMake, which is kind of the newer Make. Makes things a lot simpler, or it does some stuff for you that GNU Make does not. So a lot of times you have to pair GNU Make with some auto tools, the GNU auto tools, AutoConf, AutoMake, things like that. And if you've ever tried to read a Make file produced by those tools, it's insane. They're pretty crazy. CMake is a lot more readable, a lot more friendly to a user, and it's capable of a lot of the things that all of those auto tools are able to do. The other benefit is that CMake is really well supported cross-platform. So it works well in Windows. In fact, it will automatically generate a Visual Studio project for you. So you tell it what your files are that need to be compiled. It will actually generate the project for you and can call MS-Dev and actually build it through Dev Studio, which is really nice. We also looked at Maven. Maven, if anyone's familiar with it, it's almost like an ecosystem in and of itself. There are a lot of requirements. There's a lot of overhead, if you will, and it's very geared for Java. So it works fantastic. I have to admit, it's actually a really cool system. But if you're not in Java, or you're doing anything slightly out of the ordinary for a normal Java project, then Maven starts to really get in the way for you. It has a lot of requirements, and if you don't follow them exactly, then things start to go bad really quick. We've had a lot of experience with it, actually, and most of that has not been overly well, except from a developer standpoint. So if you're a developer working on a project, to be able to grab the dependencies and integrate that, it's fantastic. If you're trying to create a robust, reliable build system, then you either have to kind of go all in to Maven or avoid it at all costs. And so it's one of those cases where trying to shoehorn our stuff into it wasn't something that we were really interested in doing. Apache Ivy was another solution. And Ivy is a dependency control system that they have some really interesting concepts and ideas. If you look at their website, it's interesting how they kind of bash on Maven a little bit for convoluting the two parts to the building, the dependency management and the actual compilation. And in some ways that's good. Maven certainly has its purpose in doing that. But Apache Ivy and Apache Ant are kind of two separate sides to that puzzle. Ivy will do the dependencies, Ant will do the build. And so putting those two together actually was a really good solution for us. And in the case of C, adding CMake to this list was actually kind of a benefit as well. Might look a little bit of a convoluted mess here if you actually look at it, a build system with both CMake and Ant, but as it turns out, our build system, we wanted to be kind of this one solution that works for everything. So we made that Apache Ant and Ivy. CMake does a really good job of checking dependencies, but not so good of a job of retrieving dependencies. So by combining that with the capabilities of Ivy through Ant, we were able to create a complete solution for C builds as well. The other nice thing is that once you get one of these source distributions that's in C, if you don't want to use Ant and Ivy, which is kind of unnatural for C developers, you don't have to. You can actually run everything with CMake, and it works just fine. So we just have a really small wrapper of Ant and Ivy around that to make it consistent with the rest of our builds. I should probably mention, if you have any questions, feel free to interrupt me and let me know. I'll try my best to answer them. So with our build process identified, we knew what we were going to do there. We needed to find something that was going to be able to run all of these builds and manage them. So some of the options that we looked at there was Jenkins. It's another very popular build automation tool or suite. Again, very, very geared towards Java. It certainly works for other purposes, but its main purpose is primarily building Java builds. There's another one called Bamboo, yet another Atlassian product, and it also integrates well with source control, Jira, and the like. As it turns out, this is a case where we didn't go with the Atlassian tool, and not because there was anything wrong with it, but it was still a little bit geared towards Java builds. You could define other things, other processes to build, but ultimately we didn't really want to learn yet another solution. So we were already adopting new source control, new defect control systems than what we were using internally to Panasonic. And there was a really good product that we had already very well used. Yeah.
I hate Bamboo.
Do you? Oh, well, fantastic. We're glad we didn't pick that one then. So I'd heard some good things about it. We didn't honestly look into it a whole lot because we already had QuickBuild. It was working very well. We had a very difficult to understand build process using QuickBuild, but we figured we could probably simplify that a lot by using Ant and Ivy. And because that was where we were having the most challenges, is doing the dependency management through QuickBuild. It wasn't built for that. It does work for that. It's just not, trying to get all that automated was quite a challenge. So since we had a lot of experience with QuickBuild, we wanted to just go ahead and use that. We were familiar with it already, and it works really well. Once you have your builds already set up, it's easy to define, okay, build this is how you build it, and it just works. You point it at a repository and it goes. And it met all of our needs and expectations, so we were happy with that one. So that's the one that we chose there. Continuous test solutions. That got to be a little bit sticky. We had quite an interesting challenge as OpenDOF because we have a lot of libraries and we focus on protocols. So we have these protocols that need to interoperate with other implementations. So we've got a C implementation, we've got a Java implementation, we've got a C# implementation, and we want to make sure that they all talk to each other in a lot of different ways. There's a lot of configurability, a lot of flexibility, and we wanted to make sure that they communicate well with each other. Which means if you're going to test C against Java and C#, but now you release a new version of C, well, it needs to test against Java and C#. And then you release a new version of Java, and it needs to test against the two versions of C and C#, and the previous version of Java. And before long, you get a lot of these releases, and you get this combinatorial explosion of what needs to be tested against what. And we got tired of constantly saying, okay, well, now we have to add this test, and now we have to add this test, and now we have to add this test. They were all the same test, it was just different versions of the library that we were using. And in fact, the test itself was often the same. We just needed to link against a different library, or in the case of Java, just drop a different jar into the folder and run it. So honestly, we couldn't find a good solution for this. We looked around a bit, but didn't really find anything that really fit our purpose. We had developed a couple of things at Panasonic that didn't really pan out. There was always a deficiency in them. One thing or another. We actually went through about 3 different iterations of this to our current system, and even that has some deficiencies that we don't like, and we're trying to move away from that. So we're really kind of looking for a solution here, but could not find one that met all of the requirements that we had. So we actually had kind of I'll call him brilliant. He's a really good guy. He had a great idea of how to design a test system that could understand artifacts, understand if artifacts changed or didn't change, how to test those artifacts, how to actually automatically construct builds based on descriptions of artifacts, descriptions of tests that we have, and the resources that we use. So whether they be network resources, compute resources, whatever. And so we actually started developing our own distributed testing framework, called the DTF. And this one, as it turns out, is not related to OpenDOF. This is a Panasonic thing. However, we made it open source as well. So this one's actually available on GitHub. Which turned out, as Panasonic, it was the fastest way to actually get something open source, is just create an account on GitHub and put it there. In this case, it doesn't have a build, it doesn't have any other artifacts that we have with it. It is just a source repository, and you copy it, it runs based off of Node.js, and it will just kind of do its thing there. There's a Java process that runs as well, and it does a great job of just handling a bunch of tests. So what we do is it's able to take descriptions, essentially definitions of what the tests are, and it will automatically generate the actual tests that need to run based on that. So it knows the different versions of the C libraries, the Java libraries, C# libraries, different tools, different artifacts that we have, and it knows what it needs to do with each of those based on some scripts. And so it will actually go and figure out from the scripts, it will figure out what tests it needs to generate and actually create this large list, hundreds of thousands of entries of the actual tests that it needs to run. It is able to allocate the resources that it needs, so it allocates a machine to run the server, let's say, and it allocates another machine to run the client, and then it allocates a network cable between them and connects them. And so we can define really cool things about that network cable, like we can break it and we can reattach it, and we can have a machine go down, or we can have a machine come back up. We can also define a resource as a collection of these things. So if we have a distributed system we want to set up, we can actually have a cluster of machines that we set up and configure in a certain way. And then that itself becomes a resource. And somebody wants to test against that resource, that cluster of machines. They can do that. And when it's done, it can understand that this is a cluster of machines, and I can now pull it apart into separate machines, and I can still reuse those machines for other purposes by deploying new software on them, removing what was on them, putting new software on them, and essentially making a good reuse of the resources that we have. It was actually built based on Amazon Web Services, so that we can actually spin up new machines very easily off of it's a cloud-based resource. Start up a machine, let it run, but we didn't want to incur extra costs for having it spin up a machine, run a test for a minute, and then turn it off, because you get charged for a whole hour. So we wanted to actually bring up that machine and run a bunch of tests with it and utilize it as much of that hour as we could before we take it down, or leave it up for a couple of hours, or even a few days. The other thing that we wanted to be able to do is to have a really good trade-off between our deadline and the cost that we want to pay for testing. So if we need a lot of testing to happen really quickly, we end up paying a little bit more because we spin up more machines. But it's a parallelized process. As long as we've got machines that we can use to run the tests, then they can all run in parallel. and then we just end up paying more for that month. If we don't need all those resources, we can scale it down, tell it there's only a few machines that it can run, and it'll take longer to run, but it'll get through them all eventually since it just runs in the background 24/7. And of course, it actually executes the tests. Once it deploys everything, once it hooks up everything, it'll actually execute the tests and collect the results, generate the logs, or collect all the logs, screen, console output, log files. It'll actually even do Wireshark captures of all the network packets that are going back and forth and save those as part of the execution of a test. So if something goes wrong, we have a lot of information to delve into and figure out what went wrong, why it went wrong, and what we can do about it. In the case that it succeeds, then all that's just thrown away because we don't, if it succeeds, it's good. And we don't need to debug that one. And finally, of course, it does reporting. So once all the tests have run or in the middle of running, you can find out how many are currently running, how many are left to run, what's the current state of the framework, and find out what things have failed, what things have succeeded, kind of get either a high-level view of everything, or you can drill down into the details on specific tests. What has worked? Are there differences between this version and that version? So a lot of powerful reporting capabilities. Another thing that we needed was to be able to distribute our code to the users. Talked about this a little bit at the beginning as one of the challenges that we had doing this or sharing these files, these artifacts with Japan. But when you consider that they might be halfway across the world, we wanted to look for a solution that would make getting our files, getting our artifacts easy, quick, and convenient no matter where you were in the world. So we knew we wanted to have a cloud server, so we looked into just having a cloud server do that. There are some challenges in doing that in the sense that you need to replicate that across the world. Amazon is fast, but it's still, you still have to cross an ocean if you're running just a server here in the US, or if you're just running a server in Japan. Uploading that file can take a little bit of time, especially when you're doing continuous builds and maybe want some of those builds available. At what points do you sync those? How fast does that occur? That kind of thing. And so there's also a certain level of management that comes with actually running a server. So whether it be Apache configuration or using some additional tool, there's configuration, there's management, there's maintenance, there's monitoring that is all involved with this. And we wanted kind of a hands-off solution as much as possible. So there are content delivery networks. These can help out significantly by delivering your assets to a CDN, and they will distribute it among their servers, and then when people come and ask for it, it gets served off of the closest server. So that's a good option. We like that approach, but we were trying to figure out, okay, which one do we go with? What would be a good solution for that? So as it turns out, Amazon has a really good CDN, and since we were already using Amazon for some of the other things that we wanted to host, we figured let's take a look at their CloudFront offering. And what CloudFront does is it's basically a CDN. They've got servers all across the world, and it can actually replicate your artifacts, replicate your software, and put that in various places throughout the world. And when people come to ask for it, then they'll get a close mirror of that. It'll actually download really, really quickly. And the other cool thing with Amazon is that it can actually be backed up by Amazon S3. So we don't even need a server to host anything and then run CloudFront on front of that. We actually could just host everything in S3, put things in an S3 bucket, and CloudFront would do its thing and make it available to the internet. We just have to set up a domain name and configure CloudFront appropriately. So that was a real benefit because in that case, we don't have to do anything. We just put stuff into an Amazon bucket and it shows up on the web through CloudFront. Another thing that we, let's see. So another thing that was really cool about our choices with Apache Ivy is that all it really takes to have an Ivy repository is just a directory structure. You put files in a directory structure and you kind of define what the pattern is that you use in order to find artifacts, and then you point Ivy at it and it just magically finds things. So that was really good. We knew that we could just upload files, and it turns out that Ivy repositories are compatible with Maven as well. So you kind of kill two birds with one stone, so to speak. People who want to use Maven can use Maven. People who want to use Ivy can use Ivy, and it works for both purposes. And so there was one caveat that we ran into, though, in this entire solution. We got it all set up. We could see it through our web browsers. Everything worked fantastic. We were super excited. Then we ran Ivy, and it couldn't find a thing. And so we were trying to debug this and figure out, well, why can't it find anything? We can see everything just fine. We go to this URL, it's there. We go to this URL, it's there. Everything's working fine. All the configuration's correct. What's wrong? Turns out Ivy uses directory listings in order to find a lot of the things that it's looking for. So if it knows a specific path, that's great. But there are a lot of things that Ivy tries to infer through directory structures as well. And because of that, it requires seeing those directory structures. As it turns out, S3 does not support that feature. So despite having CloudFront and S3, it was great for all of our artifacts, but we couldn't get directory structures. So we actually wrote a little tiny error handler, configured CloudFront to say, was it CloudFront or S3? One of the two. I think it was CloudFront that we configured a little error handler. If you get an error and can't find something, go here instead. And the go here was a little application that took the URL that they were trying to go to, looked up everything in S3 using Amazon's APIs, and spit out an HTML file of the directory. Ivy is really, really forgiving on what these things look like. As long as there's a name and a URL, you're good. So we made a really, really simple wrapper that just created a listing of everything in that directory inside S3, and that made Ivy happy. So that was actually, did require a little bit of coding on our part, but it was a really simple thing to do as well. So yeah, covered that. Directory listing error handler. And then, let's see. For web presence, we wanted to find a good solution where we could, like I mentioned earlier, build a community, have some discussions, maybe forums, mailing lists, things that we can pull together. And so we looked at a couple things. Obviously, there are a lot of different content management systems that you can use. And they have a lot of the same features. And honestly, our recommendation would be to just pick one that you like. In our case, we went with WordPress because it was simple to configure. One of our employees actually had a lot of experience with it, knew how to set it up, knew how to make sure it was secure, and could enter all the content for us and everything on there. And so we went ahead and went with WordPress. But there are a lot of options here for CMSs, and probably any of them are going to be good and adequate. There are a few team collaboration suites that cover content management as well as team collaboration. But what I mean by team collaboration is part of that community gathering, allowing people to send messages to each other to collaborate on what needs to happen in the project. Because as you work on a project, you need to be able to understand, okay, I'm working on this section, you're working on this section, let's not step on each other's toes. And I need to merge, or you need to merge, or whatever. We need to coordinate between different individuals and different groups on what's happening on the project. And so we needed to make sure there was a way to do that. There are some plugins for WordPress that would work for that, but there were a couple other things that we looked into as well. Another product from Atlassian is Confluence. This is a great kind of, I don't know what to call it other than a team collaboration system. It allows you to build web pages, or just pages, I guess I should say. Allows people to edit those pages. You can actually see real-time edits as they're going on. So it's a good way to actually have people all working at the same time on a particular website. The other one that a lot of people are familiar with is, of course, SharePoint. This is a Microsoft solution again. Very, very elaborate. There's a lot of capabilities that SharePoint has. We have a tendency to shy away from Microsoft stuff, so we weren't too interested in it. We actually ran a SharePoint server for a while, and yeah, there you go. It had its purpose, but we ran into some challenges with it as well. We wanted to automate some things, and it just was not working very well for us to automate those. So we ended up having to do some things manually that we had preferred not to, but it is what it is. It's a good solution, though. I mean, there's a lot of things, a lot of capabilities that it has. We've actually used Confluence in a number of projects now for inside Panasonic, but we have not we've not recommended SharePoint a lot of the reasons because of the licensing costs for that. Confluence has a reasonable for open source projects. Again, it's free. Confluence has a kind of steepish licensing cost if you're not open source. So inside Panasonic, since we're not open source and we're using them internally, we actually have to pay for the licensing fees there. But they're not too bad. And we've actually set up a system very much like this, using Confluence instead of WordPress. But everything else the same for a number of different projects inside Panasonic that have asked us to kind of help them out with running a system like this. As it turns out, what we do use, in addition to WordPress, is a product called Causeway. One of the things that we got as a benefit for as the OpenDOF project, we didn't want to do a lot of the business management that comes with an open source company or with a nonprofit organization. And so it is a nonprofit organization, and we contracted out essentially all the business stuff to this company called VTM. And they have a product called Causeway that allows for collaboration between different groups. Has mailing lists, you can do voting, you can, there's a lot of things that it integrates with the business process, but also can be just a benefit to the community. And so if you're a contributor or a committer on any of the source systems for OpenDOF, then you'll have access to this. Most general users wouldn't have access to this because they don't need it. They can certainly go there, but it requires a login that they wouldn't have. But it's a nice system, and I can show you some of the features of all of these in just a second. So combining everything, we had already kind of decided to host everything in the cloud. So we used Amazon Web Services to host pretty much all of the servers and all of the features that we wanted. The Elastic Compute Cloud, EC2, we're actually running an M3 large with Bitbucket and Jira running on the same host. We've got a medium running WordPress, and we've got a medium running QuickBuild and DTF, the testing framework. So as it turns out, I would probably say that the medium is just a slightly underpowered for doing what we want with QuickBuild. Sometimes it gets a little slow, so we might bump that up to a large at some point. And part of that reason is just because we have so many builds that are running just constantly. Whenever we make a change, it has a lot of churn that happens. And so as it checks all the things that need to occur, sometimes it gets a little slow at times. We have a relational database set up through RDS. We set up MySQL through Amazon. One of the nice things with RDS is that they manage everything for you. You don't have to worry about doing backups. You don't have to worry about doing maintenance, upgrades. They just kind of do all that for you in the background. You have to be aware of it because occasionally your back end goes down and they do an upgrade and then everything comes back up. So you can end up with some outages if you're not aware of them. As it turns out, though, that they're really good about communicating that and making sure that it happens during a specific window of time, or you can do it on your own when there's a convenient time for you. But they automatically handle the backups, they'll snapshot everything, and it's kind of a hands-off, you just get a database you can play with and use. And for us developers that we're not all DBAs, actually I don't think any of us are DBAs, so it's nice to have a DBA in the cloud, so to speak. We didn't have to worry about that. We use S3, as I mentioned, to store all of our assets. Put them on, we just dump it into a bucket there with a particular directory structure. We threw CloudFront on top of that so that we get nice distribution everywhere across the world. And one thing I didn't mention, but always is needed, you need DNS resolution. So we use Route 53 from Amazon as well to handle all of our domain names and route people to the right places. So that's pretty much where we are. So demos, if anybody wants to see these systems, let me pull them up. All right, so let's see. So our source system is, this is a view of our Bitbucket server. So we've got a couple of different overall what they call projects, which are just different groupings of the different repositories that we have. So we've got a core repository where we put all of our core stuff. We've got a data transfer set of tools and utilities and libraries that are built on top of the core, but they're specific to transferring time series data. We've got some tools that you can use, developer tools that are useful, and a bunch of training information. So we actually have some Eclipse plugins that you can download Eclipse. You put these plugins in and it'll actually walk you through step by step of developing applications using our OpenDOF technology, which is really cool. But you can dig down into any one of these and actually see the different repositories that there are. And for each of those repositories, of course, it's a complete Git directory structure. So you can look at the branches, you can switch to any of the branches that are available. You can see kind of a timeline of how things are put together, where the branches are coming from, when they get merged back in. I believe if it ever loads here. Maybe not. There's another really cool tool from Atlassian that's, again, free if you, it's a list of all the different branches and kind of their commit history, when they were updated, how many pull requests there are, whether they got merged in or not. So it's kind of there's a lot of cool things that Bitbucket allows, and it manages a lot of the process for you. So you can deal with the pull requests, you can look at the changes. There's a lot of diff utilities that are integrated here, so you can look at what one tree looks like against the other tree, see all the differences that occur. And as you're reviewing, say, a change for a bug, you can very easily see what has changed, what has not changed, walk through each of the files, and then approve or deny the commit. That's kind of a useful tool. There's another, what is it called? I think it's called Source Tree, which is a client-side developer tool and has a lot of really cool features in it as well. You can use any Git client that you want, but Source Tree is one that actually works quite well. And of course has perfect integration with Bitbucket. You can actually tell it to check out in Source Tree. So it's got some integration with the browser, and you can actually just click that button, opens it up in Source Tree, which is really nice. This is a list of all the different projects that we have in our bug tracking system. So we've got quite a list of different projects that we run. So there's more pages on the bottom there, but these are some of the ones that we've got. And for each of these, you can go in, look at the different bugs that there are for each of those. You can log bugs. You can track things. There's integration between the bug system and the Git repository. So I think I mentioned that earlier, where you can actually look at a specific bug and see all the commits that are related to it. So in fact, one that I can show you real quick that I know has a ton of them because it's assigned to me and I use it as a dumping ground for a lot of things. Let me see if I can find it. This one. So if you look over here, there's one branch associated with this bug. There's 41 commits, 2 pull requests that have been merged. I can create a new branch if I wanted to for this bug. I can, if there's actually a branch created, it'll show me what that is and I can close it or create a merge or a pull request. So kind of a fun thing. This one's actually complete now. So actually, I should probably change that to resolved. That's why it keeps showing up on my list. So that's our bug system. And here's QuickBuild. There's, I can't remember if, this used to be called LuntBuild at one point. There was an open source project called LuntBuild, and the commercial side of it was called QuickBuild. I think they just merged the names now to QuickBuild, and you can get an open source license. But it's by a company called PMEs. And they're actually very responsive. So if you have any issues with their system, they get back to you pretty quick. But you can actually build different branches very easily. All of the different builds that we've got. And of course, red indicates it failed, green indicates it's good. We've got all of our version information is checked here. We've got all of our different libraries, tools, training. Everything that we build is all encompassed in here, and it's very easy. You can trigger a build if you want, trigger it manually, or every 15 minutes it automatically just checks if the source has changed, it'll trigger a build automatically. So there's a lot of cool things that you can do with QuickBuild. I'm actually an administrator on the system, so I have lots of cool, fun things to play with that not everyone does, but it's actually quite a useful tool. Looking at asset.opendof.org, this is our little shim of a directory structure listing. So I just pulled up this is straight off of our asset site at the root level. So these are all the directories that we have at the root level, and you can drill down into any one of these, and this is exactly what Ivy will do, is it essentially comes into this IB2 directory and it looks for, okay, I'm looking for the Java OAL, let's say. And so here it is, and what versions are there? Oh, there's 4 different versions. Which one do you want? Let's go for the latest. And there's some information about it here, which is an Ivy file that talks about how to find all the other stuff, what the artifacts are, what their name is, extensions, things like that. And of course, you can download all of those through a parallel directory structure under artifact. So if we go to core Java, there's the OAL. We've got the same versioning. And we've got actually some jars. You can download the jars directly if you want. So relatively easy to navigate, but of course, a lot of this happens behind the scenes because Ivy does this for you. But if you ever wanted to go to it yourself, you can certainly do that as well. And it doesn't look like a normal Apache directory listing because it's not. It's just our little application that just looks up what's available in the bucket and displays it. This is our website, which is hosted through WordPress. Again, we run just one of the servers on AWS is running WordPress, and so that's our website. Feel free to browse around it if you'd like, opendof.org. And this is our Causeway system, which is done by the VTM group. And that's where we have, you can do calendaring, you've got voting, set up tasks, you can have a wiki or discussions, you can upload documents, which is really handy for if you want to share certain things. We have some documents on here about some of the directions that we're going or some of the assets that we have, like how to find things in AWS, how we've set up certain things so that if anybody needs that information, it's available. And of course, you can go into the different working groups. And each of them have their own areas for news, voting, calendar, membership, all that stuff. So it's kind of a nice little system there as well. So that's that. Maybe. There we go. So, questions?
You mentioned a couple of times that existing stuff was a little slow, and that's part of why you wanted to choose new tools and kind of change things up a little bit. When you say a little slow, are you talking like minutes to download a file, hours, days, extra seconds? Like what?
For the most part,
do you get?
it was maybe like half a minute extra to download some of the stuff. So it was enough to be annoying,
Sure.
but it's not, it wasn't a critical issue, but it was something that the teams in Japan had always mentioned to us every time we went. It's like, man, it's just so slow to get an update.
Sure.
And so they often wouldn't, and which frustrated us because we'd fix a bug and then they'd complain about the same bug. It's like, did you ever get the update? Oh, no, we never downloaded that. It took forever. Like, great. So, yeah, it was an excuse that they used a lot. I don't know whether it was just an excuse and they had other issues too, but that was kind of the thing that they kept mentioning to us. So that's one of the things that we wanted to make sure we handled, was handling distribution to wherever. And I think another major part of that is, like I mentioned, on the Panasonic internal network, we've got some really, really small pipes between the US and Japan. And where we were sitting, we had actually send packets, I think, to California, so from Utah to California to New Jersey and then to Japan. So it was like, why? But that's just the way things were set up. So we don't have a lot of control how things are connected, but and there are a couple of those pipes that are small and get used by a lot of different things inside the company, and so it wasn't very reliable. I shouldn't say it was reliable, it's just not fast. So doing it over the internet would have honestly solved most of the problems just right there, but at the time it was all internal code. We didn't have permission to send it over the internet. Had to stay on the internal network. Now that it's open source, we had that option available to us, and so we latched onto it quite heavily. Any other questions? Yeah.
Sounded like you had stuff on both GitLab or GitHub and Bitbucket, and I'm wondering what kind of outside participation you've seen as Bitbucket being a barrier to entry for outside participants. Like, how many people have actually come in and joined in on those that are sitting on Bitbucket versus your other stand? It's probably not apples to apples, if you will.
Yeah. Honestly, we haven't had contributors on either of them.
Really?
Sadly. Part of it, I think, is the sheer magnitude of what we've got. So this technology has actually been developed inside Panasonic for the last 10, 11 years and was just made open source last year. So as you saw, version 7, that's actually where we're at. It's version 7 of our software. And so it's not like a 1.0 release or a 2.0 release. We've had a long history inside Panasonic of making releases and updates, improvements, new features, and it's very robust now. But we're talking. I'm trying to remember how many lines of code. I know it's well over 100,000 lines of code, but I want to say it might even be 500,000 in all of our different libraries and things that we have. So for somebody to start contributing to that might be a little bit of a barrier to entry right there. Having said that, the testing framework is new. That's just been developed over the last about 6 to 9 months. And that is available on GitHub. I have not looked recently, but last time I looked, there wasn't any other contributions to it other than us. Part of that's probably, we haven't really been marketing it. We haven't pointed people at it, but it is there. In fact, I can show you.
So a little bit tangential, but what was, and I missed the beginning, so apologize if you already answered this, but what was that's typically a key into it, like, key factor in somebody deciding to open source, so what was the instigator in moving to open source, if that factor was, the factor of outside contribution was lacking, and so minimal.
Yeah.
Again, kind of tangential, but.
Yeah, no, it's a really good question. One of the things that we have found, so let me back up. We started out as a really small company called EMware many years ago. I think it was founded in 96, 95 or 96, somewhere around there. And their motto was any device, any network. And they were totally into IoT, Internet of Things, but before IoT was ever a buzzword. And I actually started working for that company in 2000, and all the engineers there were really dedicated to this technology, and we always wanted to see it as open. As EMware, it was a little bit more open in that we would actually give it out to people. They had to pay a licensing fee, of course, but then they could have access to the software, they'd have access to the source, and it was kind of a nice setup. When Panasonic came in and bought out all the technology, they actually hired some of the engineers, I was one of them, and they closed off everything. They told all of our current customers, all the EMware customers, that, sorry, this technology is no longer going to be available, we're closing the doors, sorry, goodbye. And so they cut off all of our external visibility and said, okay, we want this technology, but we want it inside Panasonic. We don't want anyone else to have access to this. We're going to use it for our own stuff. And we were all disappointed by that because we wanted to essentially change the world. We wanted to build the best networking solution that there was. And we believe that we have, based on what what we've seen from other people and other alternatives for IoT solutions, but we were forbidden of talking about it to anybody and all this stuff until finally we were able to convince the bigwigs that this kind of technology really needs to be out there in the world, that we need to essentially get people on board to adopt it, for one, and be able to talk about it because it would solve a lot of problems that we're seeing in the space around IoT and devices. One of those actually being security. A lot of people don't think security is very important, especially these Kickstarter projects where you just kind of throw something together, you throw up MQTT and sending a bunch of stuff all over the place. And then as an afterthought, it's like, oh, hey, we probably should put some security on that. All right, SSL. And SSL does, certain things, but it doesn't do everything. And there are still some issues with how people use SSL. So we think that tacking on security after the fact is not really the best approach. And our solution actually integrated security from the get-go. We developed it with security in mind from the beginning. And it's been a challenge on the one hand because we want to keep it as accessible and usable by anyone that wants to use it. But we also wanted to make it very easy to do security. And easy and security usually don't go hand in hand. So we did our best to try and bridge that gap. So we're somewhere in the middle. It is certainly a little bit more difficult to do security, but the nice thing is that our libraries don't really change. You basically set up security in one section of your code, and then it just works everywhere else. And so you actually can develop everything non-secure, throw in security, and as long as it still works, you're good to go. If it doesn't work, then you probably messed up permissions somewhere. Good question, though. That's kind of why we went open source. We felt that the community, the world would actually benefit from having this available. And we were able to convince the people in Panasonic that was not only true, but also would help further Panasonic's ability to essentially make money on this. They've dumped millions of dollars into the development of this thing and haven't actually used it in a whole lot of places. There are a few products that have it in Japan, but not so much in the US. And so that always frustrated us as well, but we wanted more adoption, and we've actually been seeing a lot more adoption even within Panasonic now that it is open source. And other companies, other organizations are much more willing to look at it now that it's open and not closed, unproprietary. Let's see, I was going to search for, if you search for Panasonic distributed, then the only thing that comes up is our project. So Bitbucket, by the way, does the same thing where it'll automatically expand readme.md files. So that's been beneficial. But yeah, this is the code for the testing framework. And a little bit about it here, talking about what we do. So there's that. Other questions? Cool. All right, well, thanks very much. This was actually given at Open West, and I had more of an audience here than at Open West, so give yourselves a hand. It was fun to give this at Open West. Actually updated the slides a little bit, found a couple of errors, so updated the slides and went from there. So thank you.